Hello students, I am Saurav Kumar and today I am going to discuss motion of center of mass. Okay, so let's start the topic, which is very one of the important topic for conservation of linear momentum also. Okay, so let's see what is happening in motion of center of mass. As we know, the acceleration of center of mass can be given as m1a1 plus m2a2 up to n number of discrete particles upon total mass m1 plus m2 plus mn. If we will assume a system of n number of discrete particles, let's say these are m1, m2, mn minus 1, mn, okay, and their individual position from the center coordinate axis, okay, is, let's say this is r1, this is rn minus 1, and so on, this is rn. Okay, so we can write acceleration of the center of mass of the system will be in this way. Okay, so the net force can be written as, the net force on the system can be written as total mass. Okay, this is total mass, that is sum of all these masses into acceleration of center of mass, this value. Okay, in this way we can write the net force. Also we can write the forces acting on the individual masses. Okay, sum of the forces acting on the individual masses, so we can also write it in this way, like m1 a1 m2 a2 m3 a3 mn am. Okay, so this is the basic thing. Till now we are aware of these formulas. Now what we will study in motion of center of mass, let's discuss a condition when the net force on the system will be 0. Okay, so what happens if F net is equal to 0? If F net is equal to 0, then if F net is equal to 0, what can be said about center of mass? Obviously the center of mass, acceleration of the center of mass will be 0. Yes, so acceleration of the center of mass will be 0. Now if the acceleration of center of mass is 0, can we say that acceleration of a1, a2, these are also equal to 0? So keep in mind, let me discuss with one example. Let me erase this. Let's say there are two charges, Q and Q. Okay, now let's say the distance between them is r. Let's say the mass of this is at point A, this is at point B. Let's say the force acting on this is F. So similarly they will have electrostatic force equal and opposite direction, magnitude wise equal, direction wise opposite. Let's say the mass of charge at A is m and mass of charge at B is 2m. So the net force on the system will be 0. Net force on the system will be 0. So I can say F net is equal to 0. So obviously I can say acceleration of center of mass is also 0. Okay, so what about the acceleration of the charge at A? Let us write the acceleration of the charge at A. Let's symbolize it A. Okay, I am writing the acceleration of this individual charge. I am not talking about the system right now. Okay, so I can simply write force on charge at A upon mass of charge at A, simply. Okay, Similarly, I want to write acceleration of the charge at B. What I can write, acceleration of charge at B can be written as force upon mass is 2a. Now these are not equal accelerations, okay? Actually acceleration at A is twice of acceleration at B. So if these charges are released, let's say at t is equal to 0, what will happen? They will separate themselves, okay? And due to the initial acceleration, the initial velocity will be 0. Initial velocity will be 0 if they will released, okay? But due to the acceleration, after some times they have some velocity. So if I have to write at any time, let's say t, if I want to write the velocity, then I will write Va will not be equal to 0 and Va will be equal to what? Va will not be equal to 0 and here also Vb will also be not be equal to 0, okay? So Va and Vb are not constant and they are non-zero values. Acceleration is also non-zero value. So from this illustration, what I can conclude here, that if net force on the system is 0, the acceleration of the center of mass can be 0. Absolutely it will be 0, but the individual acceleration will not be equal to 0. It is not necessary condition, okay? If this is equal to 0, this implies this will equal to 0. This doesn't imply that this will equal to 0 for sure. Now, if acceleration of the center of mass is 0, what I can say? I can say, second point, if acceleration of center of mass is equal to 0, this implies velocity of center of mass will be constant. Yes, of course it is constant. So it doesn't mean that V1 will be constant and V2 will be constant. Here we can see Va is not a constant value. Due to the acceleration, this value will continuously increase. Here also due to the acceleration, this value will continuously increase. So if center of mass, velocity of center of mass is constant, this doesn't mean that V1 is equal to constant and V2 is equal to constant, okay? Here, now what we have concluded till now, if net force is 0, acceleration of the center of mass will be 0 and the velocity of the center of mass will be constant. This is true. These two statements are true, but it is not necessary that acceleration of individual particles of the system will be 0, okay? Similarly, individual velocity will not be constant, okay? So from here now we can again conclude. Let me erase something. Let me erase this stuff and again this also. So what we can say after that, let's say talk about the momentum. If net force is 0, what we can comment about momentum? So if net force is 0, m1 v1 plus m2 v2 plus mn vn will remain constant. Yes, this is true, will remain constant, okay? Now again, what about the kinetic energy? See, the net kinetic energy can be given as half m1 v1 square plus half m2 v2 square, okay? So half m1 v1 square plus half m2 v2 square can be written as like this. Kinetic energy net of the system can be kinetic energy of 1 half m1 v1 square plus half into v2 square and so on, and this term will not be constant or conserved. Okay, if I have to write here, this will not be equal to constant. So these are the basic meanings of what we can understood about the motion of center of mass. If net force on system is 0, the net acceleration of the center of mass is 0, the net velocity of the center of mass is constant, but it doesn't mean that the discrete particles or the individual particles of the system will have 0 acceleration or they have constant velocity. Their velocity will be different, their acceleration will be non-zero, and hence the momentum will be conserved of the system for the system, because net force is 0, then dp by dt is equal to net force. So dp by dt must be p must be constant. Okay, so here we can write the net momentum will be conserved, but the net kinetic energy, it is not conserved or constant. Okay, how the kinetic energy they are here in this case, how they are getting the kinetic energy? Because of their individual electrostatic potential. Okay, here they are getting electrostatic potential energy, and due to which they are getting their kinetic energy. So these are the important terms which can be asked, and already they have asked in some statement wise or true false wise, okay, in exams. And on behalf of these concepts we will try to solve some examples. Okay, so let's do some example. So I am erasing these terms. So till now what we have learned, that if a system is at rest and net force is 0, then the net acceleration will be 0 of the center of mass, and the velocity of center of mass will remain constant. So if a system is at rest, let me write here, if a system is initially at rest and F net is equal to 0. Okay, if the system is at rest initially and the net force is 0, then what we can write? Center of mass, acceleration of center of mass will be 0, and v of center of mass will be 0. Why? Velocity of center of mass remains constant since they are initially at rest. So velocity of center of mass will be 0, and after any time this will remain same, that is constant, yani 0, that means. Okay, so on behalf of this concept there are many problems that can be solved. For example, let's say one question, that a very basic question. Let's say there is a platform or a plank, okay, placed on a ground surface. This is smooth surface, and a person at one end, okay, is moving towards this direction. Let's say the length of the plank is 10 meter. Okay, mass of the plank is, let's say, capital M is equal to 20 kg. Mass of the person, let's say small m, is equal to 50 kg. Okay, so the question is, when this person will reach up to this end, how much distance this will shift. Okay, so first of all, what we have to find? We have to find the distance shifted by this plank. This is a plank when the person or the man will reach at this end. Okay, so here in the question, the surface between the contact surface between the ground and the plank is smooth, but the contact surface between the man and the plank is not smooth. Why? Because if it will be smooth, he will not be able to walk. Then when the man will start walking, it will push the surface in backward direction, so the friction act on the man will be in forward direction. Okay, and the friction will always come in pair, so this friction will try to move this plank in backward direction. So what our concern is that when the man will start walking towards this end, let's say this is end B and man is standing at end A. So when the man will start walking towards end B, the plank will start moving towards backward direction. Okay, and if you draw the FBD, then this is the man. Okay, so the friction acting on the man will be in this direction, and the friction acting on the plank will be in this direction. Okay, and since they are equal and opposite, so for a system of block man and plank, for a system of combined man and plank, the net force will be 0. Okay, so this is our basic concern. Now if the system, for the system of plank and man, the net force is 0, so what I can write? F net is equal to 0. Okay, since the system is initially at rest, so what I can write? Velocity of center of mass is also 0. Till now what we have got from this given question and situation, F net is 0 and VCOM is 0. So what I can write? So here I can write, if the center of mass is at rest, means the center of mass will be at its initial position when the man will come to this end B. Okay, so let's say that I am drawing here, let's say this was the initial situation and the man has started walking from A to B, and let's say the plank has shifted something at a distance x. Okay, so the plank has shifted up to x. Let's say this distance is x. So this was the end B. Now end B has shifted to this position. So up to how much distance the man has to be finished? Okay, so man has to complete this much distance only, I think, by geometrically. So this distance can be written as how much? The total length was 10 meters, so this distance can be written as 10 minus 6. So I can write, if VCM is 0, so here I can write, let's see, mass is small m, so 50 into 10 minus x can be written as mass of plank 20 into x. From here we can find out the value of x, which will come out, I think, 500 minus 50, so 70x. So x can be written as 50 by 7 meter. Okay, 500 minus 50x, so 70x, so 500 by 70. Is it? So it was the basic example. Okay, when a plank is given and a man is moving. Okay, So what we have seen this in this example, see, first thing, find out is the net force is 0, okay, in which direction it is 0, that is also our concern. Second, is the VCM is 0, yes. Now if they are 0, in which direction F net is 0, in x direction, so we can apply this, okay. Now in x direction the plank is moving along the horizontal direction, so the plank is moving in backward direction, so the backward shifting is equal to the forward shifting, okay. Next question we will see another example. So let's say a board problem, okay, it is also a very famous one in center of mass chapter. So let's see that question. Let's say there is a board, okay, let me erase all of these. Let's say there is a boat and a man standing here, and another man is here which is also standing here, okay. Let's say this is M1 at position 1 and this is M2 at position 2, and this is all the river, okay. There is no friction between river and boat surface. Mass M1 is given and the mass of boat is, let's say, capital M, okay. So M1 is 60 kg, M2 is 40 kg, and capital M mass of boat is again 20 kg, okay. And length of boat is, let's say, L is equal to 10 meter, okay. These are the data given. Now our first concern is when they will interchange, then what will be the shift of center of mass. So first is when both will interchange their position, then find net shift of center of mass. So we have to find x, okay, net shift of center of mass. Our first question, let's see, we will discuss on this, then second question I will discuss, okay. And the second question is when they will come to at the center, what will be the net shift of the boat, okay. So first let's say they have interchanged their position, means M2 will come to this end and M1 will come to this end. So what will happen if they will interchange their position? So I am assuming that this boat will shift to backward direction. If the value will be negative, then our assumption will be change, okay. So let's say, okay, first of all, this is a system of boat plus M1 and M2, okay, man 1 and man 2. There is a system of boat plus these two men, okay. Any external force is there? I think no. So net force is 0. Initially the system is at rest, so center of mass will be at rest, that is VCM is equal to 0. Now let's shift the boat, okay, x direction. Let's say the boat had shifted here, okay, x distance, okay. say this distance is x. Now this is the person M1 and this is the man M2. So the distance traveled by the boat x, the distance traveled by the man to reach that opposite end will be this distance. I think how much? This is L and this is L minus x. Okay, so what it will be? L minus x. L is given as 10 meter. Similarly, the distance traveled by 2 to reach the opposite end will be L plus x. So what will be this distance? This distance will be L plus x. So see, boat is moving backward, this man is moving backward. So backward will be same and forward direction will be in another side of the equality. Okay, so what we will write? M1 into L minus x. M1 is moving in rightward direction or forward direction. Okay, is equal to M2 into L plus x, because M2 is moving in backward direction or leftward direction, plus mass of boat capital M we have mentioned into x. Now putting the values, M1 is equal to 60 into L minus x, 10 minus x is equal to M2 is equal to 40 into 10 plus x plus capital M 20 kg into x. Okay, now evaluating the value, 600 minus 60x, so what we will get? 600 minus 60x is equal to 400 plus 60x. Okay, so 60 120, this implies x is equal to 200 upon 120, which will be equal to 5 by 3 meter. That is the required answer. Okay, our assumption is correct. We have assumed that in this direction boat is shifting. Since the value is positive, so our assumption is correct. Yes, the boat will shift in backward direction by a distance of 5 by 3 meter. Okay, so I think we have understand what is the concept behind this motion of center of mass question. Now let's a little bit change this question. Let they are not interchanging their position, but they are meeting at the center. Okay, so I am just erasing this and let's frame a new question in this question. Okay, so let's erase this. I hope you have understand. So in the same question, now let me erase this question. When both meet at center, then find x. Okay, if they will meet at, let's say this is center C. Okay, the total length is 10 meters, so this length will be 5 and this length will be also 5. Again same funda we have to apply. Since the net force is 0 and center of mass is still at rest, so we can say VCM is also 0. So let the boat has shifted to x. Same concept, same process we will apply. Let's shift the boat to backward direction. I am assuming backward direction shifting. So now this is the center, the initial center. If the boat has shifted to x, let's say this is the boat has shifted to x and the center has shifted to this. this is the center and this is the center. This was the initial center and this is the final center of the boat. Okay. Now if the boat has shifted to x, so the center has also shifted to x. Okay, this will also be written as x. Now here is the person M1, here is M1 and here is M2. Okay, now they have to meet at center. Now the new center is this. Okay, so this person has to move up to a distance of this distance he has to cover. Okay, let me erase some here. So now this M1 has to cover this distance. I think this distance is visible. Okay, and this M2 has to clear this distance, or he has to travel this distance. So see, this is 5, this length is 5 meter, total length is 10 meter. So center from one end, the center is at a distance of 5 meter. So 5 plus x is equal to this distance. So M2 has to travel 5 plus x and M1 has to travel 5 minus x. Okay, so this distance is 5 minus x. Okay, and the boat will travel x. I think I am clear. Okay, so what I can write, M1 is moving in forward direction, M2 and the boat both are moving in backward direction. So for the shifting, the shift of M2 and shift of boat we will write along together, and M1 we will write on the another side of the equality. So M1 into 5 minus x is equal to M2 into 5 plus x. Okay, into capital M of boat, mass of boat is capital M, into x. Putting the value again, what we will get, 60 into 5 minus x is equal to 40 into 5 plus x plus 20 into x. Solving this, 300 minus 60, 40 plus 60, 20, 80, 60 and 60, 120. So 300 and 200, 100, 300 and 200, 100 is equal to 120x. So x will be equal to 10 by 12 is equal to 5 by 6 meter. Since it is positive, so our assumption is still correct, that the boat will shift in backward direction up to a distance of 5 by 6 meter. Okay, I think I am clear. In this question what we have did, since net force is 0, still net force is 0 and still the center of mass is at rest. So here BCM is 0 and Bnet is 0. Okay, ACM is also, acceleration of the center of mass is also 0. Okay, so here we have just assumed that the boat is shifted to x distance in left direction or backward direction, and M1 has to move up to center. Now center has already shifted to x distance, so M1 has to just move for a distance of 5 minus x, and since the center has shifted to x distance, M2 has to move 5 plus x. So since M1 is moving in positive x direction, I am assuming forward as a positive, so M1 into 5 minus x is equal to, boat and M2 both are moving in negative x direction or backward direction, so M2 into 5 plus x plus M1 mass of boat into x. Okay, then solving this we have got our required answer, which is 5 by 6 meter in backward direction. I hope you are getting the good understanding of this question. Let's discuss another question. Okay, So these are basics questions. Okay, let's discuss. See, in this question what we have seen, one thing, that the net force is 0. Okay, the net force is 0 in one direction. Also the net force is 0 in every direction. Okay, for a system. Okay, we will see some examples in which the net force is only 0 in some particular direction. So if the net force is 0 in a given direction, only in that direction we can say acceleration of center of mass is 0, and in that direction we can apply the further process. Okay, so we will see some example also. Let's see. uh, let's see. Let's say a wedge is there, an inclined wedge is there. This distance is, let's say, 4 meter, 3 meter, and mass of the wedge is, again let's say capital M, which is 20 kg. Okay, every surface is smooth. And this is a small block, small m. Okay, the contact surfaces are frictionless. Okay, this angle is, let's say, 53 degree. This height is 4 meter, and this length will be 5 meter. Okay, this length is 5 meter. This is end A, this is end B. Every surface is smooth, there is no any friction. Okay, all the surfaces are smooth. So when this small block will reach at the bottom P, how much the wedge will shift? Okay, so that is the basic question. Now in this question, now we will apply that concept, that F net is 0 in which direction. Okay, that concept will be applied in this direction. Till now F net was 0 in all the directions. Okay, in both the example, boat example and plank and man example. Here F net is not 0 in every direction. How? Let's see. Force on the block in y direction continuously, mg is acting. Okay, now force on the small block in x direction 0. Okay, means external force we are talking about, we are not talking about internal force. Internal force means we are just including the external forces, like normal force we are ignoring here. Okay, we are assuming normal force is internal force, we are just assuming the wedge and block as a system. So the external force is there, yes, mg is there. In which direction? Vertical direction. So what we can write, net force in y direction is not equal to 0. Yes. Okay, when we will draw the LBD diagram we can see also. Okay, now in x direction net force is 0. Yes. So here ACOM in x direction will be 0. Yes. Okay, system is released from rest. Here the block has released from rest. So VCM in x direction will be 0. That was the basic thing. Now the shifting, all the shifting of the wedge and the block will be taken only in x direction. That you have to keep in mind, because the net force along x direction is only 0. Okay, so if this block will come to this point, how much distance they will shift, this wedge will shift, that we have to find out. So let's draw here. Let's say initially the condition was like this, okay, like this. Now let's say the wedge has shifted to this position, okay. So let's say the wedge has shifted to x, okay. Now if the wedge has shifted to x distance, the block, here is the block have to come here, okay. So the x displacement, we have to concern about the x displacement, okay. The displacement along horizontal direction, here the displacement, the length along horizontal direction is 3 meter. So here also we have to concern about the this length only, okay. So when the block have to reach to the bottom, how much horizontal distance the block has to travel? I think this is the horizontal distance the block has to travel, which is 3 minus x. From this we can conclude this, okay. So what we can write, mass of wedge into this x is equal to mass of block into this, simply, okay. So what we can write, mass of capital M into x, mass of wedge into x is equal to mass of small block into 3 minus x. Simple, just putting the value. How much is the value? Let's say M is 10 kg, okay. So 20 kg into x is equal to 10 into 3 minus x. Now 30 and this is 10, so 30x is equal to 30. This implies x is equal to 1 meter. And since the direction is, the x is positive, that means the wedge will shift to backward direction for 1 meter distance, okay. So this is the way to solve the question. We don't have to take this length, okay. We have to just concern for which direction the net force is 0. Only that direction we will consider for taking the motion of the center of mass. That's why I have discussed this question, okay, only because of these conditions, okay. Now I hope you have good understanding for these situations. Let's move our last question, okay. There are many more questions in this topic, okay. Today we will discuss only 3-4 questions. I am erasing it. Let's say there is a rod and there is a ring, a bead, okay. There is a bead which is connected with a block. The mass of block is capital M and the mass of bead is small m, and this is length of string is L, okay. This is the situation given. See, all the surfaces are smooth. What is the question? It is question from Irodov, okay. This question is from Irodov. When there are 3 or 4 parts of this question, I am discussing one of them. So when this string will be at some angle, let's say 37 degree from the horizontal, Okay, find the shift of the bead. Find the shift of bead shift of ring when the block will make an angle of 37 degree with horizontal. Okay, assume all the surfaces are smooth and frictionless. Another part is also when this block will completely vertical, like in this position, then find the shifting of the bead or ring. Okay, so we will discuss also that question. Till now what we have to do. So how we will solve this? Again we have to first uh, get that in which direction the net force is 0. Okay, is it 0 in all the direction, or is it 0 some particular direction? Because only in that direction we can apply m1 x1 is equal to m2 x2, or if it is in 0 in y direction, then we will apply m1 y1 is equal to m2 y2. Okay, so let's draw the FBD of this combined system. At this position I am drawing the FBD diagram. Okay, so let's say, see, this is the ring. If the surface is smooth, then friction, no need to show the friction. So this will be the normal. This will be the mg. I am assuming small m for mass of ring, okay, or bead. Okay. Now this is the tension. So this will be the tension in the string. This is also T, and there is a block. So mass of the block is capital M, so mg, I think. Okay, this angle is 37. Yes, I think this is the required FBD for both the or for the system of bead and block. Okay, here clearly what we can see, there are forces along x direction, y direction, but there is no net force in x direction. So what I can write here also, that F net in x direction is 0, but F net in y direction is not equal to 0. Okay, so this was the basic concept that we have to find out from this question by drawing the free body diagram. Now just simply taking this point, we have to just evaluate the shifting of the center of mass along x direction only. Okay, we don't have to concern about the y direction. Okay, so what we have to do, let's say this diagram has to be drawn clearly. Let's say the bead had shifted to this position. So this is like this. Okay, this is, let us say the bead has shifted to x distance. Let me erase this. This is x. Okay, this was initial and this is final. I am assuming it as a final till now. Okay, this was initial, this was final. Okay, so if the bead has shifted to x, this block has shifted to how much distance? See, total distance is given, I think not given in data. We have assuming capital M is equal to 2 kg, small m mass of bead is equal to 1 kg, and length, let us assume 1 meter, 2 meter. Okay, 2 meter. So here what I am taking, how much the horizontal distance this block has shifted, that horizontal distance we have to find out. That means if the bead has shifted to x, how much this distance in horizontal direction block has shifted. Okay, this angle is 37. So see, this is x, the total length is 2 meter, so it is 2 minus x. Okay, so what will be the value of this length? If I want to write this length, that means this length, what will be the value of this length? This is the L, this is the 37, so this length will be L cos 37. If this is L, which is equal to 2 meter, and this is 37, so this length will be L cos 37. Okay, and the total length is L, so L minus x minus L cos 37. So what will be this value? L minus x plus L cos 37. I think we are correct. Okay, so what will be the value come out from here? L is equal to 2 minus x minus L cos 37. What is the value of cos 37? 4 by 5 into 2, so 8 by 5. So 8 by 5, so 2 minus 8 by 5 will come out 2 by 5 minus x. Okay, 2 by 5 minus x, which is the distance shifted by block. Okay, how, in which direction it is shifting? It is shifting towards leftward direction or backward direction. And in which direction the bead is shifting? Towards rightward direction or forward direction. Okay, so what I can write? I can write m small m for bead into x is equal to capital M for block into 2 by 5 minus x. So here what we have to find out? We have to find out x, putting the values. Capital M is equal to 2 and small m is equal to 1. So 1 into x is equal to 2 into 2 by 5 minus x. Okay, solving this, 4 by 5 is equal to 3x. So 3x is equal to 4 by 5. This implies x is equal to 4 by 15 meter forward direction. Okay, so this is the basic required answer. When the block will shift up to a angle of 37 degree, the bead will shift to x direction in forward direction for a distance of 4 by 15 meter. 15 it is. Okay, 15 meter. I think it is correct answer. If just see the calculation. Okay, maybe the mistake can happen also, but I think I am right. Okay, so this is the first part of the question. Second part, if they will ask you what will happen if this block will vertically hang, how much the distance the bead will shift. Simple. So just we have to calculate in this portion. We can, let me erase at this portion. This portion I am just erasing. Okay, so here let us write the second part of the question. When this bead will when the string will hang vertically, let's say initially the string was in this situation, the block was it is. Now when the, let's say the bead has shifted to a distance x, okay, and the block is hanging up to this position, again we have to find this distance, shift of this distance. Okay, and this is x, we have to find x actually, Now see, this total length is again L is equal to 2 meter. Okay, L is given as 2 meter. This is 2 meter. Okay, now, and this is x, so this is 2 minus x, simple. This length is 2 minus x, this is 2. Okay, so this is 2 minus x. Now it is easier one. Okay, this portion is the easier one. So small m into x is equal to, this is the capital M and this is the small m, is equal to capital M into 2 minus x. What is the value of small m? Small m is 1 kg. So 1 into x is equal to 2 into 2 minus x. So 4 minus 3x. So 3x is equal to 4. This implies x is equal to 4 by 3 meter, again in forward direction. So I hope you enjoyed this video. Thank you.